Hello there, and welcome to the Sleepy Space Channel. There may have been a solar system here before our own. A first generation of worlds, circling close to the young sun, finished and complete long before the Earth existed, and then gone, unmade, in a slow and silent upheaval. The planet that unmade them is still here tonight, the largest world in our sky, and one of the brightest. As it drifted inward toward the sun, a young Jupiter may have driven those first worlds into the fire, leaving only the rubble from which our own Earth was quietly rebuilt. Tonight, we follow that lost beginning, from the first cold cloud to the still ground beneath you. If you find these slow explorations of the night worth your time, a like or a subscribe helps the channel reach others who do. Thank you for being here. But for the next couple of hours, none of this is anything you need to carry. The upheaval is ancient, and it is long finished. Settle in. Let your shoulders soften. Let your breathing slow. Let the day fade away. Let's begin. Our solar system has a quiet secret folded into its very arrangement, and it is a sobering one. For most of human history, we believed we understood how the sun and its planets came to be. The story was orderly and gentle, a single calm birth out of a cloud, with every world settling into the place it was always meant to hold. That story is not wrong, exactly. It is incomplete. And the part that is missing is strange enough that, once you see it, you cannot quite look at the night sky the same way again. The missing part is this: there may have been a set of planets here before our own. A first generation of worlds, circling the young sun in the warm space near its light, complete and finished long before the Earth had taken shape. And then they were gone, unmade, in a slow and silent upheaval, leaving behind only the rubble from which our own planets were quietly rebuilt. The planet that did the unmaking is still here. It is the largest world in the solar system, and on certain nights, it is the brightest wanderer you can see. This is the story we will follow tonight, and there is no need to brace against it. The events were ancient beyond easy imagining, and they ended before there was anyone here to witness them. What they left behind is the steady, patient world you are resting in right now. But to understand how unusual that world is, we have to begin where the older story begins, with a cloud of gas drifting in the dark between the stars. The solar system began about 4.5 billion years ago, and it did not begin as a sun or as planets. It began as a cold cloud, an enormous drifting region of gas and fine dust, mostly the lightest elements, hydrogen and helium, with a faint seasoning of heavier material. Those heavier atoms, the carbon and oxygen and iron that would one day make stone and water and living things, had been forged inside earlier stars that had already lived their lives and scattered their substance back into space. The cloud was, in a sense, an inheritance. For a long time, this cloud simply drifted, thin and cold and patient. Then, something disturbed it. Perhaps the shock wave of a distant star ending its life rolled through and pressed the gas closer together. Perhaps the cloud simply reached a point where its own faint gravity could no longer be resisted. Either way, one denser pocket within it began to fall inward, each part of it pulling on every other part, the whole region beginning a collapse that would take it from a cold haze to a blazing star. As the pocket fell together, it did something that anyone who has watched a spinning skater will recognize. Any slight turning motion it already had grew faster as it shrank, the way a skater spins faster when she draws in her arms. The collapsing cloud could not fall straight to the center while it was turning. Instead, it flattened, spreading into a broad rotating plate of gas and dust, with a dense and growing knot of material gathering at the very middle. That central knot is where the sun was born. As more and more matter rained down onto it, the core grew hotter and more compressed, until the pressure and the temperature crossed a threshold that changes everything. Hydrogen atoms began to fuse together into helium, releasing light and heat in the process, and a new star switched on at the center of the turning plate. The long, cold drift was over. There was now a sun where there had been only shadow. Around that new star lay the flattened plate of leftover material, and it is this plate that matters most for our story. It is called the protoplanetary disk, which simply means the disk from which planets are made. Everything that is not the sun, every planet and moon, every asteroid and comet, every grain of the ground beneath you, was built from this spinning disk of debris. We were all, in the most literal sense, the sun's leftovers. The disk was not the same everywhere, and that difference would shape everything that followed. Close to the new sun, the disk was warm enough that only metals and rock could remain solid. Anything more delicate was driven off as gas. Farther out, where the sun's warmth thinned, it grew cold enough for water and other light compounds to freeze into ice. Somewhere between those two regions lay a boundary, a line in the disk, with rock on the near side and ice on the far side. That boundary is called the snow line, and it is one of the most important features in the whole story. Inside the snow line there was only stone and metal to build with, and not very much of it. Outside the snow line there was stone and metal, and, in addition, a great deal of ice, which meant there was far more solid material available to gather into worlds. Where a planet was born, on the warm side of that line or the cold side, would decide what kind of world it became. For generations of astronomers, the rest of the story seemed to follow simply enough. The dust in the disk would clump together where it lay, building larger and larger bodies, until each region of the disk had assembled its own planet. The inner, warm region would make small worlds of rock and metal. The outer, cold region would make large worlds wrapped in ice and gas. And each planet would settle into the orbit where it had formed and circle there, quietly, for billions of years. It is worth lingering on the inheritance the cloud carried, because it is part of why this story belongs to us, and not only to the rocks. The heavier elements salted through the gas had each been made inside an earlier star, fused in stellar cores or in the violent endings of stars that had already finished their lives. The carbon that would one day form living things, the oxygen that would fill the oceans, the iron that would sink to the centers of worlds, all of it was second-hand, gathered from the ashes of suns that shone before our own. The cloud was a kind of memory, holding the products of generations of stars. The young sun, in its first stretch of life, was not the steady light we know now. It was a restless, active star, brighter and more turbulent than today, throwing out strong winds of particles and bursts of energy. These early outbursts mattered because they helped to clear the gas of the disk over time, and they swept the lightest material away from the warm inner region. The sun was not a passive center around which everything else happened. It was an active force, shaping the disk, even as the disk shaped the planets. The flattening of the cloud into a disk is worth picturing slowly, because it explains so much of what came after. A cloud that collapses while turning cannot fall straight inward. The turning resists the fall in every direction except along the axis of the spin. So the material settles toward a single plane, the way a ball of spinning dough flattens into a disk under a cook's hands. This is why the planets all circle in nearly the same plane today, lined up like the grooves of a record, rather than scattered at every angle. The flatness of the solar system is a fossil of that early spin. All of this took time, but not as much as you might expect for so grand a result. The collapse of the cloud and the lighting of the sun unfolded over a span of perhaps 100,000 years, which against the age of the solar system is a single, quiet morning. The disk that fed the planets lasted only a few million years before the gas was gone. Worlds had to be built quickly, on the scale of these things, gathered together before the material that made them dispersed into the dark. By the time the gas had cleared, then, the broad shape of a planetary system was already set in motion, and it seemed to follow so naturally from the rules of gathering that there was little reason to question it. Small worlds near the sun, large worlds far out, rubble scattered between. It is the arrangement we recognize, and it appears to fall straight out of the simple physics of dust and gravity and time. The picture was clean, and it was satisfying, and it held for a very long while. It is a calm and reasonable picture, and for a long time there was no reason to doubt it. The planets we could see were all arranged in tidy, nearly circular orbits, lined up in order, behaving themselves. But the picture had one quiet weakness. We had only ever seen a single planetary system from the inside, our own, and we had assumed it was ordinary. We had no way of knowing whether our calm arrangement was the rule or the strange exception. That assumption was about to come undone. Before we can understand what went wrong, or rather what went strangely, we should understand how worlds are built in the first place. The process is so slow and so patient that it is almost restful to follow, a matter of small things gathering into larger things over enormous stretches of time, without any hurry at all. It begins with dust. The disk around the young sun was full of microscopic grains, particles of rock and metal and ice, no larger than the specks that drift through a beam of afternoon light. These grains drifted through the gas, and now and then 2 of them touched. When they touched gently enough, they stuck, held together by the faint forces that make fine particles cling. A grain became a pair. A pair became a clump. This sounds almost too simple to build a planet, and on its own it would be. But the disk was patient, and it was crowded, and there was a great deal of time. The small clumps swept up more grains as they drifted, growing into pebbles, and the pebbles gathered into fragile clusters, and the clusters, where they grew large enough, began to feel a new force entering the process. They had become massive enough that their own gravity, faint as it was, began to help them gather more. Once gravity enters the story, growth changes character. A body large enough to pull on its neighbors no longer has to wait for chance collisions. It begins to draw material toward itself, sweeping a path through the disk, gathering the smaller bodies in its reach. These growing worlds are called planetesimals when they reach the size of mountains and small moons, and embryos when they grow larger still to the size of the Moon or Mars. The disk became a population of such bodies, thousands of them, all circling the sun. Then the embryos began to find one another. Their gravity reached out and stirred each other's orbits, bending the once circular paths into gentle ellipses that crossed. Where orbits cross, bodies eventually meet, and when 2 planetary embryos meet, they do not pass politely. They collide, and if the collision is not too violent, they merge into a single larger body. World by world, the population thinned, the survivors growing larger as they absorbed their neighbors. In the warm inner region, inside the snow line, this building had a hard limit. There was only rock and metal to work with, and there was not a great deal of it, so the worlds that formed there stayed relatively small. These became the terrestrial planets, the worlds of stone and iron, with solid surfaces you could stand upon. In our system, they are the 4 innermost planets, and they are modest in size compared to what lies beyond. In the cold outer region, beyond the snow line, the building had far more to draw upon. The abundance of ice meant the growing cores out there could become much larger, much faster. And once a core grew large enough, something remarkable happened. Its gravity became strong enough to seize not just solid material, but the gas of the disk itself, the hydrogen and helium that made up most of its mass. The core began to draw a thick atmosphere around itself and kept drawing, swelling into a giant. This is how the giant planets were made, and it is why they are giants. They formed a large solid core early, while the disk was still full of gas, and then they gathered that gas in enormous quantities, wrapping themselves in atmospheres thousands of miles thick. The largest of them gathered so much that it became, by a wide margin, the most massive planet in the solar system. We will come to that planet very soon, because it is the center of our story. There was a clock running over all of this, and it is worth keeping in mind. The disk of gas did not last forever. The young sun, growing more active, gradually blew the gas away, and over a span of a few million years, the disk thinned and cleared. A planet that wanted to gather a thick atmosphere of gas had to do it before the gas was gone. This is why timing matters so much in the story of how the planets formed. Being early or being late changed everything about what a world could become. So by the time the gas had cleared, the broad outline of a planetary system was in place. Small rocky worlds near the sun, large gas-wrapped worlds farther out, leftover rubble scattered between and beyond them. It is the arrangement we recognize today, and it seems to follow naturally from the simple rules of gathering and collision we have just traced. And yet, when we look closely at the details, the arrangement does not quite add up. The inner solar system, in particular, is shaped in a way these gentle rules do not predict. The trouble is hidden in the sizes and the spacings, in how much material ended up in each place and how much did not. To a casual glance, the inner planets look fine, 4 worlds in a row, going about their orbits. But to anyone counting carefully, comparing what is there against what the building process should have produced, the inner solar system holds a quiet puzzle. There is too little in some places and a strange emptiness in others. Something does not fit. There is a refinement to the building of worlds that is worth adding, because it shows how patient the process truly was. Growth did not proceed at a steady, even pace. There were stretches when a body that had grown a little larger than its neighbors began to pull ahead quickly, sweeping up the smaller material around it, faster and faster, as its gravity strengthened. This runaway gathering let a few bodies grow into dominant embryos, while most of their neighbors stayed small. The disk became a place of a few large winners, moving among a crowd of smaller bodies. The gas of the disk played its own quiet part in shaping the growing worlds. While the gas was still present, it acted like a gentle resistance, slowing the smaller bodies and nudging their orbits toward neat circles. It helped some material spiral gradually inward and smoothed the motions of the growing planets. Only after the gas cleared did the embryos begin their final, freer phase of colliding and merging, no longer cushioned by the surrounding gas. The presence or absence of gas changed the very character of how worlds came together. The last phase of building the rocky planets was the most dramatic, and it is one we can still see the marks of today. With the gas gone, the surviving embryos, dozens of bodies the size of the Moon or Mars, moved on crossing orbits and collided in enormous impacts. These were not gentle mergers but world-shaking strikes, each one capable of melting a planet's surface or knocking it sideways. Our own Moon is thought to have been born from such a collision, a glancing blow to the young Earth that threw enough material into orbit to gather into a companion world. This giant impact phase is why the inner planets are as few and as large as they are. Out of the original crowd of embryos, only a handful survived as full planets, each one the winner of a long series of collisions, having absorbed its rivals. The terrestrial planets we know are the last survivors of a much larger population, the bodies left standing after the rest had merged into them or been flung away. Every rocky world is, in a sense, a composite built from many smaller worlds that no longer exist on their own. So the building of worlds, gentle as its beginning sounds, ended in a series of titanic collisions that decided which planets would exist. It is against this backdrop of merging and impact that the rest of our story unfolds, because a system being built through such collisions is a system that can also be unmade through them. The same physics that gathers worlds together can, with a large enough disturbance, set them colliding in ways that destroy rather than build. That possibility is exactly what the inner solar system seems to record. We turn now to that puzzle, because it is the thread that, when pulled, unravels the older story and reveals the stranger one beneath. The inner solar system is not arranged the way a calm and undisturbed birth would leave it. It looks, on close inspection, like a place where something large once passed through and rearranged everything, and then left. To see why, we only have to look at what is missing. The inner solar system, the warm region where the rocky planets circle, is strangely empty in places it has no business being empty. This is the first clue, and for a long time it was easy to overlook because it is a puzzle about absence, and absence is hard to notice. You have to know what should be there before you can be troubled by its not being there. Consider first the space closest to the Sun, the region inside the orbit of Mercury. It is simply empty. There are no planets there at all, nothing circling in that warm, bright zone between the Sun and its innermost world. At first, this seems unremarkable. Perhaps that region was always too hot or too thin to build anything. But hold that thought, because when we look at other stars, we will find that this inner zone is exactly where planets most love to gather. Our empty version is the unusual one. Consider next Mercury itself, the small world that does circle there. Mercury is odd in a specific way. It is not just small, it is unusually dense, carrying a great iron core that takes up most of its body, wrapped in only a thin skin of rock. It is as though a larger rocky planet had most of its outer layers stripped away, leaving the heavy metal core behind. A world built quietly and left alone should not look like that. Mercury looks like a survivor of something rough. Consider then the planet that troubles the old story most of all, which is Mars. Mars sits out at the edge of the inner system, and by the simple rules of gathering, a world at that distance should have had plenty of material to draw upon. It should have grown into something substantial, a planet perhaps as large as the Earth or Venus. Instead, Mars is small. It carries only about a tenth of the Earth's mass, a stunted world that seems to have stopped growing while it was still young. This is known as the small Mars problem, and it is a genuine difficulty. The building process we traced should have given Mars far more material than it ended up with. For Mars to be so small, the supply of building material in its region must have been cut off early, before the planet could finish growing. Something must have removed the bricks before the house was done. But the calm, undisturbed birth offers no reason for that. The bricks should have been there. Consider, finally, the asteroid belt, the band of rubble that lies between Mars and the giant planets. We sometimes imagine the asteroid belt as a crowded, dangerous place, but it is the opposite. It is almost empty. If you gathered every asteroid in the belt together into a single body, the result would be smaller than our moon, a tiny fraction of a planet's worth of material. The belt is not a planet that failed to form so much as the faint leftover of one that was mostly taken away. And the belt is strange in another way, beyond its emptiness. The objects in it are sorted oddly. Closer to the Sun, the asteroids tend to be dry and rocky, made of the stone and metal that belongs to the warm inner region. Farther out, they tend to be darker and richer in ice and water, the kind of material that belongs beyond the snowline. But the two populations are partly mixed together, dry bodies and icy bodies sharing the same band, as though they had been scattered there from two different places and stirred together. None of these oddities is dramatic on its own. A small Mars, a thin asteroid belt, an empty inner edge, a stripped little Mercury. Each could perhaps be explained away by itself, with enough patience. But taken together, they form a pattern, and the pattern points in one direction. The inner solar system looks like a place that was once disturbed. It looks swept. It looks like a region where most of the material was gathered up and carried away, leaving behind only the survivors and the scraps. Set against the survivors, there are the well-fed worlds. Earth and Venus are robust, full-grown planets, close in size to one another, sitting in a relatively narrow band where most of the inner system's mass is concentrated. They did not go hungry. So the shape of the inner solar system is this: empty near the Sun, two large planets in a narrow middle band, a starved Mars at the outer edge, a nearly bare belt beyond. It is a lopsided, swept-looking arrangement. For a long time, these facts sat quietly in the textbooks, noted but not explained, the kind of loose threads that every field carries and hopes to tie up someday. There was no obvious culprit, no reason within the calm old story for the inner system to be shaped this way. And there was, importantly, no point of comparison. We could not say whether our swept-looking inner system was normal or strange, because we had nothing to compare it against. Ours was the only system we had ever seen. That changed within a single generation. We learned, for the first time, how to see planets around other stars. We began to count them, by the dozens, then the hundreds, then the thousands. And as the count grew, a picture emerged of what planetary systems usually look like out there among the stars. That picture was nothing like our own. It revealed, with quiet force, that the empty inner system we had taken for granted was not the ordinary outcome at all. We were the exception. There is a deeper oddity hidden in the inner system, and it concerns not just where the mass is, but how the spinning is shared out. The Sun holds almost all of the mass of the solar system, more than 99 parts in 100. And yet the Sun carries only a small share of the system's turning motion. Most of that is held in the orbits of the planets, and a great deal of it in Jupiter alone. A system that simply collapsed and settled would not naturally divide itself this way. The lopsided sharing hints that material was moved around, that the system was rearranged rather than left as it first formed. Return to Mercury for a moment, because its strangeness rewards a closer look. For a rocky world, the balance between its metal core and its rocky shell tends to fall within a certain range, set by the mixture of material it formed from. Mercury falls well outside that range. Its iron core makes up the large majority of the planet, far more than its share of rock would suggest. The most natural way to make such a world is to take an ordinary rocky planet and strip away much of its outer rock, leaving the dense metal behind. That stripping requires violence, a heavy collision, or a rough early environment. The asteroid belt holds its own quiet testimony. beyond simply being nearly empty. Within the belt, there are gaps, narrow bands cleared of asteroids that line up precisely with rhythms set by Jupiter's orbit. Where a small body would circle in a simple ratio with the giant, the repeated tugs have swept the region clear over the ages. These gaps are direct evidence that Jupiter's gravity reaches into the belt and shapes it even now. If the giant sculpts the belt today, from its distant orbit, it is no great leap to imagine what it might have done while on the move. It is also telling how little the belt amounts to compared with what should be there. The region between Mars and Jupiter is wide, and by the simple rules of gathering, it should hold a substantial mass of rubble, perhaps even enough to have formed a small planet. Instead, it holds a tiny fraction of that, less than the mass of our moon spread across an enormous expanse. The belt is not merely a place where a planet failed to form. It is a place where most of the original material is simply gone, removed by something that reached in and swept it away. Taken one at a time, these features are the sort of loose ends every science carries, noted in the textbooks and set aside for later. Taken together, they sketch the outline of a single event, large enough to empty the inner edge, starve Mars, strip Mercury, and sweep the belt, all at once. The old story of a calm, undisturbed birth has no such event in it. To find one, and to know whether our swept inner system is unusual at all, we needed something the old astronomers never had. We needed to see other solar systems. To understand the strangeness of our own beginning, then, we have to look outward, away from the sun entirely, to the other stars and the worlds that circle them. Only by seeing what is normal elsewhere can we measure how unusual we are. And only by measuring how unusual we are can we begin to ask the question that drives this whole story. Not how did our planets form, but rather what happened to the planets we should have had and do not. For all of history, until very recently, we knew of exactly one planetary system, and it was ours. Every star in the sky might have had its own planets, and surely many did, but we could not see them. They were too small, too dim, lost in the glare of the stars they circled. So we did the only thing we could. We assumed our own system was typical, and we built our understanding of how planets form around that single example. Then we learned to detect the planets of other stars, and the assumption did not survive. The methods were ingenious. A planet crossing in front of its star dims the star's light by a tiny, measurable amount, and from that faint regular dimming, we can find the planet and measure its size. A planet also tugs its star very slightly as it orbits, making the star wobble, and from that wobble we can weigh the unseen world. With these tools, the planets of other stars began to come into view. At first it was a trickle, then a flood. We now know of thousands of planets around other stars, enough to begin seeing patterns, enough to ask what a typical planetary system actually looks like. And the answer, when it came, was humbling. The typical system is not arranged like ours. In fact, the most common kind of planet in the galaxy is a kind we do not possess at all. That most common planet is a world larger than the Earth but smaller than the ice giant Neptune. It sits in the size range between the two, and we have no example of it in our own system. There is simply nothing between the Earth and our smallest giant. These middling worlds are so common around other stars that they must be the galaxy's favorite kind of planet. They are often called super-Earths, or, when they carry thick atmospheres, mini-Neptunes. Whatever the name, the lesson is the same. The most ordinary planet in the galaxy is one we lack. There is more, and it is stranger still. These common super-Earths are not found drifting far from their stars. They are most often found very close in, hugging their suns in tight, fast orbits. It is normal to find several of them packed into the warm zone near a star, circling in a matter of days, crowded into the region inside what would be, in our system, the orbit of Mercury. The space near the star is, for most systems, the busiest place of all. Stop and set that beside what we just learned about our own inner system. The region closest to our Sun, the region inside Mercury, is empty. We have nothing there at all. But that same region, around a typical star, is crowded with large planets. The place that is most populated in an ordinary system is precisely the place that is barren in ours. Our emptiness is not the rule. It is the glaring exception. This is the discovery that turned the old question inside out. We had always asked how our planets came to be, taking their arrangement as a given. But once we could see other systems, a sharper question appeared. Why is our system missing the very planets that nearly every other system has? Where are our super-Earths, our crowded inner worlds, our tight, fast planets near the Sun? By the standards of the galaxy, they should be there. And they are not. There are, broadly, two ways to answer such a question, and the difference between them is the difference between a calm story and a strange one. The first answer is that our system simply never formed those inner worlds, that for some reason the building process near our Sun was different, and the super-Earths never came to be. The second answer is more unsettling, and it is the one that fits the evidence best. Our system did form those worlds, exactly as other systems do. And then, it lost them. If the second answer is right, then the empty inner system, the stripped Mercury, the starved Mars, the swept-out belt, all of it falls into place. They are not the marks of a region that was always quiet. They are the marks of a region that was once full and then was emptied. The absence is not original. It is a consequence. Something came through the warm inner system, took away the worlds that had formed there, and left behind only the swept and rebuilt remnant we now call home. This is why the discovery of other planetary systems matters so much to a story about our own. It gave us a mirror. Held up to the galaxy, our solar system stopped looking like the ordinary template and started looking like the survivor of some particular history, a system shaped by an event most others did not undergo or underwent differently. The emptiness near our Sun became a clue rather than a given, a fingerprint left at the scene of something that happened long ago. It is worth marveling, for a moment, at how recently this mirror appeared. For nearly all of human history, no one knew of a single planet beyond our own family of worlds. Then, within the span of a single lifetime, the count went from none to thousands, and the picture of what is normal among the stars was assembled almost from scratch. We are among the first people who have ever been able to ask whether our solar system is typical, because we are among the first to have anything to compare it against. The question itself is young. The crowded inner systems found elsewhere have a curious orderliness that makes our emptiness stranger still. Where a star hosts several close-in planets, those planets often resemble one another closely in size and spacing, like a row of similar beads strung at regular intervals. They appear to have formed together, in place, as a settled and tidy set. This is the opposite of a system that was violently rearranged. It suggests that the default, when nothing disturbs an inner system, is a neat row of similar worlds, which is precisely what we lack. There is also a telling gap in the sizes of planets found elsewhere, a kind of missing rung on the ladder. Among the close-in worlds of other stars, there are many a little larger than the Earth, and many somewhat larger still, but comparatively few right at the divide between them. This gap is thought to mark the line between worlds that kept a thick atmosphere of gas and worlds that lost it to the heat of their star. It is the fine print of how close-in planets live and change, and it underscores how much we have learned about a kind of world we do not even possess. All of this evidence converges on a single uncomfortable fact about our own system. The close-in worlds that fill the galaxy are not a rare luxury that only some stars enjoy. They are the common case, the thing planetary systems do unless something prevents them. For our inner system to be empty where almost every other is full, our system must be the one where something intervened. The emptiness is not the baseline from which others deviate. It is the deviation, and it calls for a cause. And once you accept that the emptiness needs a cause, the shape of that cause begins to suggest itself. Whatever happened removed the close-in worlds or prevented them, while leaving a reshaped set of smaller planets behind. It cleared the inner edge, starved the outer one, and swept the belt. It was something large enough to rearrange an entire inner system, and yet something that left the system otherwise intact, still orderly, still orbiting in a plane. The list of things that could do this is very short. And so we arrive at the central possibility of this entire night, stated plainly and gently. There may once have been a complete set of planets in the warm inner reaches of our solar system, a first generation of worlds, formed early and packed close, exactly like the crowded inner systems we see almost everywhere else. They would have been finished, circling, real. And then they were removed, and our own planets, including the Earth, were built afterward, from what was left. To call that earlier set a first solar system is a turn of phrase rather than a technical term, but it carries the truth of the thing. A complete inner system existed, and then it did not. The next question is the obvious one, and it is the question that gives this story its weight. What could possibly remove an entire generation of planets, sweep the warm inner region nearly clean, and reshape everything that survived? The answer, remarkably, is not some vanished outside force. It is a planet that is still here. Let us pause and imagine the inner solar system as it may have been in its first chapter, before our own planets existed. It is a gentle thing to picture, even though it ends in loss, because for a time it would have been a complete and ordinary place, no stranger than the countless systems we now see circling other stars. In this first chapter, the warm region near the young sun is not empty. It is crowded. Several large rocky worlds circle close to the star, packed into tight orbits, perhaps larger than the Earth, perhaps several of them in a row. They would have formed quickly, while the disk of gas was still thick, and the supply of material near the sun was at its most generous. Being early, they grew large. Being close, they circled fast, completing an orbit in days or a few weeks. These first worlds would have been hot, not only from the nearby sun but from the heat of their own making, the energy of all those collisions still glowing within them. Their surfaces may have been molten or barely cooled, lit from within and without. They would have had no oceans, no gentle skies, nothing like the conditions we know. But they would have been planets in full, finished bodies circling a star, an inner system complete in itself. It is worth dwelling on how ordinary this arrangement would have been. By everything we have learned from other stars, a set of large planets crowded close to the sun is not exotic. It is the standard outcome, the thing planetary systems do by default. If anything, it is our current arrangement, with its small, spread-out rocky worlds and its empty inner edge, that is the oddity. The first generation, if it existed, was the normal solar system. Ours is the unusual sequel. And then, in this picture, the first generation comes to its end. not in a single moment, not in a flash, but in a slow unraveling that may have taken many thousands of years, which against the long life of a solar system is the blink of an eye. The stable, circular orbits of those first worlds were disturbed. Pulled out of their safe circles, stretched into crossing ellipses, the planets that had circled in peace began to wander into one another's paths. When large worlds cross paths, they do not simply pass. Over time they meet, and a meeting between planets is a collision of unimaginable force, enough to shatter both bodies into rubble or to fling them onto wild new orbits. Some of that rubble, and perhaps some whole worlds, would have been driven inward, spiraling toward the sun, until it crossed the final threshold and fell into the star itself. A planet that falls into its sun simply becomes part of it, its substance added to the fire, leaving nothing behind to find. This is the crucial and quiet point. There need be no wreckage left in orbit, no ruined planets drifting as monuments to what happened. If the first worlds were driven into the sun, they were erased completely, their material folded into the star's own glow. The only trace they would leave is an absence, an inner system swept strangely clean, and a set of survivors and scraps shaped by the violence of their passing, which is precisely what we find. So the inner solar system we know, with its 4 modest planets and its thin belt, would be the second generation. Not the original set, but the rebuilt one, assembled afterward from the leftover material, in a region that had been swept of most of its mass. Mercury and Venus and the Earth and Mars would be the younger worlds, built in the aftermath, circling in the cleared space where an earlier, larger family of planets had once circled and then was lost. There is something quietly moving in this, once the alarm of it has settled. The ground beneath you, on this account, is not part of the solar system's first draft. It is part of the second. The world you are resting in was built after a previous world had already come and gone, gathered together from the calm that followed an ancient upheaval. We are not the planet that was always here. We are the planet that was made from what remained. But all of this rests on one enormous question, and we cannot pretend otherwise. What could possibly destabilize a complete set of large planets, pull them out of their safe orbits, and drive them into the sun? Planets in stable circular orbits do not simply decide to wander. Something has to push them, and to push several large worlds out of their courses requires a force larger still. It requires a body massive enough to stir the entire inner system as it moves. There is only one object in the solar system massive enough to do such a thing, and it is not some lost or hidden world. It is the largest planet we have, the giant that still circles beyond the asteroid belt, the brightest of the wanderers in our night sky. To finish the story of the worlds that came before, we have to turn our attention to the world that is still here, and that may have been the cause of their ending. We have to turn to Jupiter. Let us dwell a little longer in that first chapter, while the picture is still whole, because there is a gentleness in it that the ending should not erase. For a stretch of time, the inner solar system was a complete and ordinary place, a set of worlds going about their orbits in the light of a young star. Nothing about it announced that it would not last. It was, by the measure of the galaxy, a perfectly normal solar system, the kind that exists in great numbers among the stars, even now. Its ordinariness is part of what makes its loss worth pausing over. We should also be honest that the first generation may not have looked exactly as we imagine it. Perhaps there were several large worlds, perhaps only a few, perhaps a crowd of medium ones rather than a row of giants. The evidence tells us that the inner system was reshaped and that close-in worlds are common elsewhere, but it does not hand us a portrait of the exact planets that were lost. We are reading their existence from the empty space they left, the way you might infer a missing painting from the clean rectangle on a faded wall. And we should resist the urge to mourn the first worlds as though they were anything like the Earth. They were not gentle places. They would have been hot, airless, lit by the fire of their own making and the nearness of the young sun, with no oceans and no skies worth the name. If they were lost, nothing that could suffer was lost with them. They were worlds in the geological sense, bodies of rock and metal, not homes. Their ending was the rearrangement of stone, not the end of anything that knew it was ending. This matters for the mood of the whole story, because it keeps the loss in proportion. We are not telling a tale of a living world destroyed, but of an early arrangement of barren planets dissolved and remade. The drama is real, the scale enormous, but the thing undone was a set of molten rocks, and the thing made from them was, eventually, the living Earth. The arrow of the story points from lifeless toward living, from a hot, crowded beginning toward the cool, quiet world we know. Still, the question of what removed those first worlds is not answered by saying they were barren. Barren or not, large planets in stable orbits do not simply leave. To pull several of them out of their courses and drive them inward requires a force on the scale of the planets themselves, a body whose gravity could dominate the entire inner system. And there is exactly one such body in the solar system, then and now, a single world heavy enough to have done it. The rest of the story is the story of that world. For Jupiter, on this account, is not merely a bystander in the history of the inner planets. It may be the central actor, the single body whose movements decided which worlds survived and which were lost. And to understand how a planet could do such a thing, we first have to understand just how large Jupiter is, and how a world that large behaves when it is young, and the disk of gas is still all around it. That is where we go next. Jupiter is the giant of the solar system, and the word giant does not quite carry how thoroughly it dominates. It is more massive than all the other planets combined, and not by a little. You could gather every other world, every rocky planet and ice giant and moon and asteroid, and Jupiter would still outweigh the lot of them more than twice over. In any honest accounting, the solar system is the Sun, then Jupiter, then everything else as an afterthought. A planet that massive is almost a second center to the whole system. Its gravity reaches across enormous distances, steadying some orbits and stirring others, shepherding the asteroid belt, herding comets, setting the rhythm for countless smaller bodies. Even today, in its calm maturity, Jupiter shapes the motions of the solar system from afar. It is the great regulator, the heavy presence around which much of the rest quietly arranges itself. Jupiter almost certainly formed first among the planets, and it formed quickly. Out beyond the snow line, where ice made solid material abundant, its core could grow large faster than anywhere else. And once that core was large enough, it began to seize the gas of the disk, drawing hydrogen and helium around itself in enormous quantities while the disk was still young and full. Jupiter became a giant by being early, by gathering its great atmosphere before the gas of the disk had a chance to clear. This early formation is important because it means Jupiter was already a fully grown giant, while the inner solar system was still busy building its small rocky worlds. The first generation of inner planets, if they existed, would have been forming at the same time that Jupiter, already massive, circled out beyond them. The giant was in place, finished and heavy, while the inner system was still soft and unsettled. The stage was set for one to act upon the other. Now here is the part that turns Jupiter from a steady regulator into the agent of our story. A planet as massive as Jupiter, sitting in a disk of gas, does not necessarily stay where it formed. The gas of the disk pushes and pulls on the giant, exerting a steady drag, and the natural result of all that interaction is that the planet tends to drift. And the direction of the drift, more often than not, is inward, toward the star. A young giant in a gas disk is a planet on the move. This inward drifting of a planet through its disk is called migration, and it was once a startling idea, but it is now thought to be entirely common. We have, again, the evidence of other stars to thank for that. Around many other suns, astronomers have found giant planets circling extremely close in, gas giants in scorching orbits that take only days to complete, worlds far too large to have formed where they now sit. These close-in giants are often called hot Jupiters. A hot Jupiter is a puzzle only until you accept migration. A gas giant cannot form right next to its star. The region is too hot and too thin for a giant to gather there. So a hot Jupiter must have formed farther out, beyond its own snowline, and then drifted inward to the searing orbit where we find it. The existence of these worlds, in system after system, is direct evidence that giant planets migrate, sometimes a very long way, sweeping inward through their systems as they go. And this raises the unsettling possibility at the center of our story. If giant planets commonly drift inward, and if our own Jupiter is a giant that formed early in a gas-filled disk, then our Jupiter may have drifted inward too. It may not have stayed in its distant orbit, beyond the belt. It may have fallen for a time toward the Sun, plunging inward through the solar system. And on its way in, it would have passed directly through the warm region where the first inner worlds were forming. Picture that, calmly. The largest planet in the solar system, more massive than everything else combined, drifting slowly inward, crossing the orbits of the inner worlds, one by one. It would not need to strike them. It would not need to touch them at all. A body that massive, simply moving through the inner system, disturbs every orbit it nears, stirring the once circular paths of the smaller planets into crossing, unstable ellipses. The disruption would be gravitational, quiet, and complete. This is the mechanism we have been searching for, the force large enough to unmake a generation of worlds. Not a collision from outside, not some vanished intruder, but the inward journey of the giant that is still with us. Jupiter, on this account, did not destroy the first worlds by hitting them. It destroyed them by passing through, by lending its enormous gravity to a slow rearrangement that pulled the first planets out of their safe orbits and set them on the paths that ended them. We should hold this gently, because it is the dark turn of the story, and the channel's purpose is rest, not alarm. The events were ancient, slow, and silent, played out over thousands of years in a solar system with no one in it. There was no catastrophe to witness, no terror to feel, only the patient working of gravity on a young and unsettled place. And the end of it, as we will see, was not ruin, but renewal, the clearing of the ground on which our own world would be built. To feel the weight of Jupiter properly, it helps to gather a few of its measures. It could hold more than 1,000 Earths within its bulk, and it carries more than 300 times the Earth's mass. A single storm in its atmosphere, the great rolling oval that has turned in its clouds for as long as we have watched, is itself wider than our entire planet. It commands a family of dozens of moons, 4 of them large worlds in their own right, and a magnetic field so enormous that, if it glowed to our eyes, it would spread across our night sky, larger than the moon. Jupiter's composition tells you what it is at bottom. A world made mostly of the lightest gases, hydrogen and helium, the same material as the Sun, gathered around a denser core far below. In truth, Jupiter is closer in makeup to a small failed star than to a rocky planet, a body that gathered a great envelope of gas but never grew massive enough to ignite. Had it gathered far more, it might have become a dim companion star to the Sun, and the solar system would have had two centers of light. It stopped short of that and remained a planet, but only just. The speed of Jupiter's formation is the detail that makes it dangerous to the inner worlds. Because ice made building material abundant beyond the snowline, Jupiter's core could assemble quickly, and once that core was heavy enough, the gathering of gas ran away with itself, the planet swelling to giant size while the disk was still young and full. By the time the inner rocky worlds were still in their slow middle stages of growth, Jupiter was already finished, already enormous, already a dominating presence circling beyond them. The giant grew up first and waited. A finished giant sitting in a disk that is still full of gas is precisely the situation in which migration happens. The gas does not let so massive a body sit still. It exerts a steady, patient torque, and the usual result is a slow inward drift. So the very thing that made Jupiter a giant, forming early in a gas-filled disk, is also the thing that set it moving. The giant's size and the giant's restlessness came from the same source. It was born large and born to wander, and the inner worlds lay along the path of its wandering. We have, again, the testimony of other stars to assure us this is no wild idea. Around sun after sun, astronomers have found giant planets circling impossibly close in, gas giants in orbits of mere days, far too large to have formed where they now sit. These scorched giants are proof, written across the galaxy, that worlds the size of Jupiter do migrate, sometimes across enormous distances, sweeping inward through their systems. Our Jupiter, on this account, began such a journey and was spared the worst of it. Many other giants were not, and they ended up roasting beside their stars. But to see how the giant's journey could both destroy and create, we need to follow that journey in detail. We need to trace Jupiter's fall inward, understand what it did to the worlds and the rubble it passed, and then, crucially, understand why it stopped, why it did not simply continue all the way to the Sun and become a hot Jupiter itself. The answer to why Jupiter turned back is the hinge on which our own existence depends, and it brings a second giant into the story. To understand what Jupiter's journey did, we should picture clearly what happens when a giant planet moves through a disk of gas and smaller bodies. It is a slow process, and like much in this story, it is more a matter of patient disturbance than of sudden violence. But its effects are thorough, and they reach across the whole inner system. As Jupiter drifted inward, it carved a gap in the disk around its orbit. A planet that massive clears the gas near its path, pushing material ahead of it and trailing it behind, opening a furrow in the disk, like the wake of a boat moving through still water. The giant rode this disturbance inward, and the gas itself helped carry it along, the whole arrangement spiraling slowly toward the Sun over a span of perhaps 100,000 years. Ahead of the giant lay the inner region, with whatever it contained, the forming worlds, and the rubble and the embryos still gathering. As Jupiter approached, its gravity began to reach these bodies, and their orbits responded. A planet that had circled in a calm near circle found its path being stretched, pulled into an ellipse, its once steady orbit growing eccentric and unstable. Multiply this across the whole inner system, and you have a region being thoroughly stirred. There is a particular way that a massive planet grips smaller bodies, and it deserves a word, because it is central to how Jupiter rearranged the inner system. When a small body's orbit falls into a simple rhythm with the giant's, completing 2 orbits for every one of Jupiter's, or 3 for every 2, the repeated gentle tugs add up, rather than cancel out. These points of matched rhythm are called resonances, and through them, the giant can grip a body and drag it along, inward or outward, far more powerfully than its distance alone would suggest. Through these resonances, Jupiter could capture material and carry it as it moved. Some of the smaller bodies were swept inward ahead of the giant, herded toward the sun. Others were flung outward, scattered onto wide and tilted orbits. The inner system, which had been a relatively orderly set of circling bodies, became a churning place of crossing paths and scattered material, all of it responding to the slow inward march of the largest planet. For the first generation of inner worlds, this was the beginning of the end. Their stable orbits, which had kept them safely apart, were disturbed by the giant's approach. As their paths grew eccentric and began to cross, the worlds that had circled in peace were set on a collision course with one another. It would have taken time, perhaps many thousands of years, but the outcome was written into the geometry. Crossing orbits eventually lead to meetings, and meetings between planets are destructive. Some of those first worlds, or the rubble they became, were driven inward by the giant's influence, spiraling closer and closer to the sun. There is a point of no return near a star, an inner region from which material does not escape, and bodies pushed past it fall inward until the star consumes them. Whole planets' worth of material may have been delivered to the sun this way, swallowed into its fire and erased, leaving the inner system lighter than it had been. This is how an entire generation of planets could vanish without leaving a wreck behind. Ground into rubble by collisions, much of it driven into the sun, the rest scattered or swept up into later building, the first worlds would dissolve from the record almost entirely. The only signature they would leave is the one we have already noted, an inner system strangely emptied, swept of the material it should have held, shaped by the passage of something large. It is worth saying plainly that this was not a malicious act, nor a sudden one, and the language of destruction can mislead. Jupiter did not target the first worlds. It simply moved, as a giant planet in a gas disk tends to move, and its movement rearranged everything in its reach. The destruction of the first generation was a side effect of gravity doing what gravity does, slowly and without intent, in a young solar system that had not yet settled into its final shape. And yet the result, however unintended, was the clearing of the inner system. By the time Jupiter reached the innermost point of its journey, the warm region near the sun had been thoroughly worked over, much of its original material removed or scattered, the first worlds gone. The inner system was not empty, but it was greatly reduced, holding only a fraction of what it had begun with, swept into a narrower and more concentrated band of leftover rubble. Now, if the story ended here, with Jupiter still drifting inward, it would end with no Earth at all. A giant that continues to fall toward its star does not stop on its own. It keeps spiraling in until it becomes a hot Jupiter, circling close to the sun in a matter of days. Had Jupiter done that, it would now be a scorched giant near the sun, and the inner system would be its ruined wake, with no room and no material to build the gentle, rocky worlds we know. It is worth slowing down on resonance, because it is the gentlest sounding idea in the story, and also one of the most powerful. Imagine pushing a child on a swing. A single shove does little, but if you push in time with the swing's own rhythm, each small push adds to the last, and the motion grows. A massive planet works on a smaller body the same way. When their orbital rhythms match in a simple ratio, the giant's repeated tugs fall in time with the smaller body's motion, and the small nudges accumulate instead of cancelling, building up large effects from gentle pulls. Through these matched rhythms, Jupiter could reach out and grip bodies far from itself, herding them as it moved. The giant swept some of the inner material ahead of it, gathering it toward the sun like a plow gathering soil. Other bodies it flung outward, casting them onto wide and tilted paths. The inner system, once a fairly orderly set of circling bodies, became a churning place of crossing tracks and scattered debris, every part of it responding to the slow inward march of the largest planet. It was rearrangement on a system-wide scale, all of it driven by gravity alone. For the first generation of worlds, the danger lay not in being struck by Jupiter, but in being unsettled by it. Their safety had depended on their orbits staying neatly separated, each world keeping to its own circle. As the giant's influence stretched those orbits into crossing ellipses, the worlds began to wander into one another's paths. The geometry alone then guaranteed the outcome. Crossing orbits, given enough time, lead to meetings, and a meeting between large worlds is a collision violent enough to shatter both. The giant did not need to touch them. It only needed to spoil their spacing. And there was a final destination for much of the disturbed material, which is the sun itself. Near a star lies a threshold, an innermost region from which bodies do not return. Anything pushed past it spirals inward until the star consumes it. Jupiter's influence drove some of the first worlds, and much of the rubble they became, toward and across that threshold. A planet that falls into its star simply becomes part of it, its substance added to the fire, leaving nothing behind. This is how whole worlds could vanish from the record without leaving so much as a ruin in orbit. It is worth saying again, plainly, that none of this was sudden or aimed. The clearing of the inner system unfolded over many thousands of years, a slow, grinding rearrangement with no one to see it and nothing to feel it. Jupiter did not hunt the first worlds, it merely moved, as a giant in a gas disk moves, and its moving rearranged everything in reach. The word destruction fits the result, but the process was patient, silent, and indifferent, the unhurried working of gravity on a young and unsettled place. But Jupiter did not become a hot Jupiter. It fell inward, reached a turning point, and then reversed, withdrawing to the distant orbit it holds today. Something stopped its fall and sent it back outward, and that reversal is the reason we exist. The thing that turned the giant around was not chance and not the sun. It was another giant, forming farther out and beginning its own inward journey, catching up to Jupiter and changing the course of both. To understand the turn, we have to bring Saturn into the story. Saturn is the second of the great giants, smaller than Jupiter, but still enormous, a world wrapped in its own thick atmosphere and circled by its famous rings. In the story of the early solar system, Saturn plays a quiet but decisive part. It is the reason Jupiter turned back, and so, in a roundabout way, it is one of the reasons the Earth had room to form at all. Saturn formed somewhat later than Jupiter and somewhat farther out, gathering its great envelope of gas a step behind its larger sibling. And like Jupiter, once it had grown massive, it too began to feel the pull of the disk and to drift inward. Saturn began its own journey toward the Sun, following the path the larger giant had taken, falling inward through the outer solar system in Jupiter's wake. But Saturn fell faster. Because of its smaller mass and the particular way it interacted with the disk, Saturn drifted inward more quickly than Jupiter had, and so it began to catch up. The gap between the two giants narrowed over time, the smaller world gaining on the larger, until the two massive planets were near enough that their gravity began to dominate each other's motion. And at that point, something locked into place. The two giants fell into resonance with one another. Their orbital periods settled into a simple ratio, so that for every few turns, one of them the other made a matching number, and the two began to tug on each other, in a steady, repeating rhythm. Once joined this way, Jupiter and Saturn no longer moved independently. They moved as a linked pair, their fates bound together, and that binding changed everything about how they interacted with the surrounding gas. For reasons rooted in the detailed way, a linked pair of giants pushes on the disk around them. The resonance reversed the direction of their drift. Instead of being pulled inward, the joined giants began to be pushed back outward, the two of them retreating together from the sun. Jupiter, which had been falling inward for 100,000 years, reached its turning point and began to climb back out, with Saturn following behind. This reversal is the turn that gives the event its name in the language of the people who study it, attacking, like a sailing ship, changing its heading against the wind. For our purposes, the name matters less than the fact. Jupiter fell inward, reached its innermost point, and then turned and withdrew, retreating to roughly the distant orbit it holds today, with Saturn settling into its own place beyond. The great inward journey ended, and the giants returned to the outer system. The timing of the turn is everything, and here is the detail that makes the whole story click into place. Jupiter's innermost point, the closest it came to the Sun before turning back, is thought to have been near the orbit that Mars now occupies. The giant fell inward to about that distance, and then it reversed. And that single fact, where Jupiter stopped and turned, explains the strange shape of the inner solar system better than anything else we have. Consider what it means. Everything inside Jupiter's turning point had been swept and worked over by the giant's passage. The material there had been gathered up, scattered, and concentrated into a narrower band closer to the Sun. But everything outside the turning point, beyond where Mars now circles, had been largely cleared by the giant's two passages, swept nearly empty. The turning point became a kind of edge, with concentrated material on the inner side and a swept void on the outer side. The first generation of worlds, if it had formed in the warm inner region, would have been destroyed during all of this, in the churning that Jupiter's inward fall produced. By the time the giant turned and withdrew, the inner system had been cleared of its original planets and left with a reshaped supply of rubble, concentrated into a band, ready to begin again. The stage had been swept, the old players removed, and the material gathered for a second act. And so the destruction and the creation are, in this story, two halves of a single event. The same inward journey that unmade the first worlds also rearranged the inner system into the precise configuration from which our own planets would be built. Jupiter did not merely destroy, it cleared and it concentrated, and in doing so, it set the conditions for the second generation, the family of planets that includes the Earth. The destroyer prepared the ground for what came after. It is a strange kind of comfort, but a real one, that the violence of the giant's passage was also the act that made our world possible. Had Jupiter not fallen inward, the inner system might have kept its first generation of crowded super-Earths, and there would have been no room and no occasion for the small, spread-out rocky worlds we know. Had Jupiter not turned back, it would have become a hot Jupiter and ruined the inner system entirely. The narrow path between those fates is the one that led to us. The mechanism that turned the giants around rewards a slower look because it is a small marvel of how gravity and gas conspire. When Jupiter alone moved through the disk, it cleared a gap and drifted inward in the usual way. But once Saturn caught up and the two locked into rhythm, the smaller giant cleared part of the same region, and the two overlapping gaps changed how the gas pushed on the pair. The balance of forces that had pulled them inward now pushed them outward instead. The reversal was not a chance event, but a consequence of two giants sharing one disturbed stretch of disk. The particular rhythm the two giants fell into was a simple one, the kind that locks bodies together most firmly. For every 2 turns one giant made around the sun, the other made a matching count, so that the pair returned to the same arrangement again and again, their tugs reinforcing in a steady beat. Such simple ratios are the strongest of the resonances, the ones that bind orbits most tightly. Once Jupiter and Saturn were caught in it, they moved as one linked system, and what happened to one happened to both. There is something almost providential in the timing, though we must remember it was only physics. Saturn had to form at roughly the right moment and the right distance, and migrate at roughly the right speed to catch Jupiter before the larger giant fell too far. Had Saturn been later, or slower, or smaller, the catch might never have happened, and Jupiter might have continued inward to become a hot Jupiter, ruining the inner system entirely. The reversal depended on a second giant arriving with the right timing, and it did. Picture the turning point itself, the deepest moment of the giant's journey. Jupiter, having fallen inward for something like 100,000 years, slows, stops, and begins to climb back out, with Saturn following behind. The inner system at that instant is a swept and churning place. Much of its first material gone or scattered, the survivors stirred into a narrower band closer to the sun. The giant pauses at the edge of the rocky region, near where Mars now circles, and then withdraws, leaving the cleared inner system behind it. That pause, near the orbit of Mars, is the single most explanatory fact in the whole account, and it deserves to be held clearly. It marks the boundary between what was swept inward and concentrated, and what was swept outward and emptied. It is why the material that would build Earth and Venus was gathered into a narrow, crowded band, and why everything beyond, where Mars and the belt would form, was left starved. The location of the giant's turn is written into the sizes of the planets we ended up with, like a watermark pressed into the inner system. We come now to the second act itself, the rebuilding of the inner system after the giant withdrew. This is the chapter in which the Earth is made, gathered from the swept and concentrated rubble that Jupiter left behind. It is the gentlest part of the story, the long, patient assembling of a quiet world out of the aftermath of an ancient upheaval. And it is the part that most deserves the word the title has been circling all along. Our world was built from wreckage. After Jupiter turned and withdrew to the outer solar system, the inner region was left transformed, but not lifeless. It was no longer the crowded place of the first generation, with its large worlds packed near the sun. It was a swept and reshaped region, its surviving material gathered into a relatively narrow band, ready to begin the slow work of building planets all over again. This second building is the one that made the worlds we know. The key feature of the reshaped inner system was that band of concentrated material. Jupiter's passage had truncated the inner disk, gathering the surviving rocky rubble into a ring centered roughly where the Earth and Venus now orbit. Inside this ring, the material was relatively plentiful. Outside it, the giant had swept the region nearly clean. The second generation of planets would be shaped entirely by where they formed relative to that band. Within the dense central part of the ring, the building proceeded much as it had the first time, but with the swept and concentrated material now available. Dust gathered into clumps, clumps into bodies, bodies into embryos, embryos colliding and merging into planets. Where the material was richest, in the central band, the building produced 2 well-fed worlds, close in size to one another. These became Venus and the Earth, the 2 largest of the rebuilt rocky planets. The Earth, on this account, is a second-generation world, gathered together from the rubble that remained after the first inner system was cleared away. The material that built it had, in part, already been part of other bodies, stirred and scattered and concentrated by the giant's passage before it came together into our planet. The ground beneath you was assembled in the aftermath, from leftovers, in a region that had been swept by the largest planet in the solar system. At the edges of the concentrated band, the building had far less to work with, and the planets that formed there show it. Mars sits at the outer edge of the ring, just inside where Jupiter turned. Beyond that edge, the giant had swept the region nearly empty, so Mars formed at the boundary of plenty and want, with its supply of material cut off early. It grew quickly at first, and then stopped, stranded as a small world, a tenth the mass of the Earth. The small Mars problem dissolves the moment you place Mars at the swept edge of the band. Mercury, at the inner edge near the Sun, tells its own version of the same story. The innermost region was a place of frequent, violent collisions during the rebuilding, and Mercury seems to bear the marks of that roughness. Its great iron core, wrapped in only a thin shell of rock, is what you might expect of a world that suffered a heavy collision, one that stripped away much of its outer rocky material and left the dense metal core behind, exposed and oversized for the small world that carries it. Mercury is a survivor of a rough neighborhood, marked permanently by the violence of the rebuilding. And the asteroid belt is the scar left by the whole process. The region between Mars and Jupiter was swept by the giant's two passages, first inward, then outward, and left, holding only a small remnant of its original material. That is why the belt is so nearly empty, why it amounts to less than a single moon's worth of rubble. It is not a failed planet so much as the swept-out gap between the inner band and the giant, a region emptied by the same journey that shaped everything else. The strange mixing of the belt also finds its explanation here. Jupiter's inward pass scattered dry inner system bodies outward, and its outward pass scattered icy outer system bodies inward, and the two populations ended up sharing the same band, stirred together. So the belt holds both dry, rocky asteroids and darker, ice-bearing ones, mixed across the region, a record of material thrown in from both directions by the giant's two-way journey. The disorder of the belt is itself a fingerprint of the event. Step back and look at what this single story explains. The empty inner edge, where the first generation was lost. The well-fed Earth and Venus, built in the concentrated band. The starved Mars, formed at the swept outer edge. The stripped Mercury, battered in the rough inner zone. The nearly empty asteroid belt, swept by the giant's passage. The strange mixing of dry and icy bodies, scattered from both directions. One event, the giant's journey inward and back, accounts for all of it at once. This is what gives the story its quiet power. It is not that any single one of these features demands such a dramatic explanation. It is that all of them, the empty places and the small worlds and the swept belt and the mixed rubble, fall into place together under one account. Several separate puzzles, each awkward for the calm old story, are solved in a single stroke by the giant's ancient journey. The persuasiveness lies in that convergence, in the way so many loose threads are tied by one knot. And there is a further gift, hidden in the rebuilding, one that touches us more nearly than any of the rest. The same churning that destroyed the first worlds and shaped the second may also be the reason there is water on the Earth at all. For the inner region, inside the snowline, was too warm for ice. A world built only from local material, there should have been bone dry. Yet the Earth has its oceans. The question of where that water came from leads us to the last twist in the giant's story. The idea of a narrow building band is worth making vivid, because it is the quiet engine of the whole second act. Imagine the inner system after the giant's passage, as a single bright ring of rubble gathered close around the orbits where Earth and Venus now circle, and thinning rapidly toward its edges. Inside that ring, material was plentiful, and worlds could grow large. At the edges, the supply fell away quickly, so any world forming there ran out of bricks while still small. The whole pattern of the inner planets, large in the middle and small at the edges, falls out of that single ring of concentrated rubble. The rebuilding repeated the same patient process we traced before, but on the swept and gathered material. Dust drew together into clumps, clumps into bodies, bodies into embryos, and the embryos collided and merged into planets, just as in the first building. The difference was the setting, a cleared and concentrated inner system, rather than a full and crowded one. From this second round of gathering came the 4 rocky worlds we know, each shaped by where it sat in the ring of leftover material. It is worth pausing on the word wreckage, because it is exact rather than poetic. The material that built the Earth was not pristine, untouched stuff drawn straight from the original cloud. It was rubble, the scattered and reworked remains of an inner system that had already been built once and then torn apart. Some of it may have been fragments of the first worlds themselves, ground small and flung into new orbits, then gathered up again into the second generation. The Earth was assembled from debris, in the plainest sense of the word. And the final building of the Earth ended, as the first building had, in giant collisions. The young Earth suffered at least one tremendous impact, a strike by a body the size of a small planet, and from the material thrown off by that blow, our moon is thought to have gathered. So even the moon, the gentlest light in our night sky, the one that has soothed sleepers for as long as there have been sleepers, is itself a child of collision, born from the debris of a strike against the rebuilt Earth. Wreckage upon wreckage, and out of it, the quiet face of the moon. Look once more, then, at the family of worlds the second building produced, and see how completely the giant's journey is written into them. The well-fed Earth and Venus in the crowded middle of the ring. The starved Mars at its swept outer edge. The battered Mercury at its rough inner edge. The nearly empty belt beyond, swept clean by the giant's passage and stirred with bodies from both sides of the snow line. Every one of these features, which the calm old story could not explain, falls naturally out of a single inward journey and its turning back. For the giant that unmade the first worlds may also have watered the second. In stirring the outer system and scattering icy bodies inward, Jupiter's journey could have delivered water to the dry inner planets, carrying the makings of oceans across the snow line to worlds that could never have gathered them alone. The same violence that erased a generation of planets may have brought to the Earth the very substance that fills its seas and makes it gentle. We turn to that final gift now. There is a problem with the Earth's oceans, and it is a quiet one that the giant's story happens to solve. The problem is that the Earth, by rights, should be dry. It formed in the warm inner region, well inside the snow line, where it was too hot for ice to survive. The material that built our planet should have been rock and metal, baked free of water. And yet the Earth has oceans, and rivers, and clouds, and a great deal of water besides. Where did all of it come from? The water could not have simply been there in the inner disk, frozen into the local rubble, because the inner disk was too warm to hold ice. The water must have been delivered, brought in from somewhere colder, from beyond the snow line where ice was abundant. Some body or bodies carried water across that line, from the cold outer reaches to the warm inner planet, and gave the Earth the makings of its seas. The question is, what did the carrying? Here the giant's journey offers an answer that fits neatly with everything else. As Jupiter migrated inward and then back outward, it stirred the outer solar system thoroughly, scattering icy bodies from beyond the snowline in all directions. Some of those icy bodies were flung inward, sent across the snowline into the warm region where the Earth was forming. Arriving there, they delivered their ice to the growing inner planets, and the ice became water, and the water gathered into oceans. So the same event that destroyed the first generation of worlds may have brought the Earth its seas. The giant's churning of the solar system was not only a clearing and a rebuilding, it was also a delivery, carrying the cold makings of oceans across the line that separated ice from rock. The Earth, dry by birthright, became a water world because the upheaval that shaped it also watered it. The violence and the gift are, once again, two halves of a single ancient event. There is something quietly fitting in this, that the planet which unmade the first worlds also helped make the second one livable. Jupiter did not only destroy and clear. Through the same motions, it delivered the water that fills our oceans, the water in the clouds, the water in every living thing. The substance that most defines the Earth as a gentle, living world may have arrived as a side effect of the giant's long journey. We owe our seas, in part, to the same body that erased the worlds before us. And once the rebuilding was done, and the water delivered, Jupiter took up a new and lasting role, the one it still plays today. The giant that had cleared the inner system became its distant guardian. From its orbit beyond the asteroid belt, Jupiter's enormous gravity now reaches inward, catching and deflecting wandering comets and stray bodies that might otherwise fall toward the inner planets. The destroyer of the first worlds became the watchman over the second. This guardianship is not perfect, and it is easy to overstate, but it is real. Many a comet falling in from the outer solar system has been turned aside or captured by Jupiter's gravity before it could reach the inner planets. The giant intercepts much that would otherwise cross the inner system, a heavy presence standing between the gentle rocky worlds and the rain of objects from the cold outer reaches. The same mass that once unmade a generation now helps to shelter the one that followed. So the full arc of Jupiter's role comes into view, and it is a strange and complete one. Early in the solar system's life, the giant fell inward, destroyed the first generation of worlds, swept and reshaped the inner system, and helped deliver the water that would fill the Earth's oceans. Then it withdrew to its distant orbit and became the steady guardian of the worlds it had helped to build, deflecting the comets, steadying the rhythms, regulating the solar system from afar. Destroyer, builder, and watchman, all in one body. It is worth sitting with how completely our existence is bound up with this single planet. Had Jupiter not formed or not migrated, the inner system might have kept its crowded first generation, with no room for the Earth. Had Jupiter not turned back, it would have ruined the inner system as a hot Jupiter. Had it not stirred the outer ice inward, the Earth might have stayed dry. And had it not taken up its later watch, the inner worlds would have suffered far more from wandering comets. At every turn, the giant's actions made our world more possible. None of this was aimed at us, of course, and it is important not to slide into imagining purpose where there was only physics. Jupiter did not set out to clear a place for the Earth, or to water it, or to guard it. It simply moved as a massive planet in a gas disk moves, and then settled where the dynamics left it, and the consequences happened to be the ones that allowed gentle worlds to form and persist. The fittingness is ours to feel, not the giant's to intend. But feel it we may, and there is comfort in it once the alarm has faded. The story that begins with the destruction of a generation of worlds ends with a planet sheltered, watered, and quietly guarded, circling in steady peace. The upheaval is over. The orbits have long since settled. The giant that once fell inward now keeps its distant station, and the inner worlds ride their patient circles, undisturbed, in the calm that the ancient violence finally produced. There are clues, written into the water itself, that point to where it came from. Water carries a kind of fingerprint in the precise mixture of its forms, a subtle signature set by the conditions under which it froze. The water in the Earth's oceans carries a signature that matches closely. The water locked in certain families of icy bodies from the outer reaches of the inner system, the kind of bodies that Jupiter's churning would have scattered inward. The match is not perfect, and the question is not fully closed, but the makings of our oceans seem to point outward, beyond the snow line, to material delivered from the cold. This delivery would not have happened all at once, but over a long stretch, as scattered icy bodies rained gently inward across the early solar system. Some struck the forming Earth and added their water to it directly. Others arrived later, after the planet had largely formed, salting its surface with ice from the cold reaches. The oceans we know were not poured in a single moment, but gathered slowly, drop by ancient drop, from bodies flung inward by the rearrangement of the outer system. The seas are, in a sense, an accumulation of deliveries. It is a thought worth holding gently as the night deepens, that the water you have drunk, the water in the rain, the water in your own body, may have begun as ice in the cold outer reaches of the young solar system, carried inward by the same upheaval that cleared the first worlds away. The oceans are not native to the warm ground that holds them. They are visitors from the cold, delivered long ago, settled now into the basins of a world that could never have made them on its own. Jupiter's later role as guardian also deserves a closer look, because it reframes the giant entirely. From its distant orbit, Jupiter's gravity now dominates the outer edge of the inner system, intercepting and deflecting many of the comets and stray bodies that fall in from the cold. Some it captures into its own orbit, some it flings back out, some it draws into itself, taking the blow that might otherwise have fallen elsewhere. We have even watched the giant swallow a comet in our own time, a body torn apart and pulled into its clouds. The watchman still works. So the arc of Jupiter's life bends, over billions of years, from destroyer toward keeper, and there is a quiet rightness in that bending. The planet that began by unmaking an inner system now spends its long maturity helping to shelter one. The same mass, the same gravity, the same heavy presence turned over time from a cause of ruin into a cause of safety. The giant did not change. Only the role it played in the slowly settling system changed, from the agent of an ending to the guardian of a beginning. As we draw near the end, then, the shape of the whole story can be held in a single view. A first generation of worlds, formed and lost. A giant that fell inward, unmade them, and turned back. A second generation, rebuilt from the wreckage, watered by the same upheaval, and guarded ever since. And at the end of all of it, the quiet world you are resting in tonight, a second draft, assembled from leftovers, holding perfectly still beneath you in the dark. There remains only to gather what we know and what we do not. It would be a mistake to tell this story as though it were settled beyond all question, and the honest uncertainties are part of its calm rather than a flaw in it. The account we have followed, of a giant that fell inward and unmade a first generation of worlds, is a leading explanation, well supported and elegant, but it is an explanation, not a recovered memory. It rests on modeling and on the shape of what survived, and it shares the field with other ideas. The deepest limit is simple to state. We have no direct trace of the first worlds. If they were driven into the sun, they left nothing behind to find, their substance folded into the star and erased. There is no recovered wreckage, no ruined planet drifting as proof, no sample we can hold. The case for the first generation rests on absence, on the strange emptiness of the inner system and the shape of the survivors, read like writing, left in the arrangement of what remains. Because the case rests on inference rather than on direct evidence, there is room for other accounts, and several exist. Some propose that the inner planets were always small and spread out, that no large first generation ever formed, and that the empty inner system is original rather than the result of a clearing. On this view, there is nothing missing. Our system simply built small worlds from the start, for reasons of its own. It is a karma story, and it cannot yet be ruled out. Other accounts accept that the inner system was reshaped, but disagree about the details. They adjust how far the giant traveled, or when, or how far inward it fell, or whether a second giant was truly needed to turn it back. There are versions in which the inner system was sculpted by the slow drift of rubble, rather than by a long inward plunge of Jupiter, and versions that explain the small Mars and the swept belt by other means entirely, without so dramatic a journey at all. The broad picture of a disturbed inner system is widely shared. The precise mechanism is still worked over. Even within the story we have followed, real questions remain open. How far inward Jupiter actually traveled, and exactly when, is refined as the models improve and as we learn more from other planetary systems. Whether the first generation was made of several large super-Earths, or fewer, or something different, is not something we can read directly. The story has a firm spine and many soft edges, and the soft edges are where the work continues. There is also the question that may never be fully answered, the one that sits at the very center. Did our system form close-in super-Earths and then lose them, or did it simply never form them at all? Both paths leave behind a similar emptiness, an inner system without the crowded worlds that other systems have. Telling the difference between a generation destroyed and a generation that never existed may be beyond what the surviving evidence can decide. The absence is real. Its cause is inferred. None of this should trouble the rest of the night, and in truth it deepens the wonder rather than diminishing it. The point was never that we know exactly what happened in the solar system's first chapter. The point is that the most ordinary features of our sky, an empty patch near the sun, a small red planet, a thin scatter of asteroids, may be the quiet evidence of a lost world. The mystery is not a failure of knowledge, but an invitation to keep reading the writing left behind. And there is a particular kind of peace in holding a story this way, as a leading explanation with its doors left gently ajar. We are not asked to believe with certainty in a vanished generation of worlds. We are asked only to notice that our solar system carries the marks of a history more eventful than its calm appearance suggests, and to let that history sit alongside the stillness, neither one cancelling the other. The night sky can be both settled and full of unanswered questions. What is not in doubt is the strangeness of our arrangement compared to the galaxy at large. Whatever the precise cause, our inner system is genuinely unusual, missing the crowded, close-in worlds that other systems possess, shaped in a way most systems are not. That much the mirror of other stars has shown us beyond question. We are, by the standards of the galaxy, an exception, and the explanation for our exceptional shape involves, in some form, the giant that still circles beyond the belt. What is also not in doubt is that the Earth is, in the most literal sense, built from material that had been part of other things before. Whether or not there was a true first generation of planets The atoms of our world were gathered from rubble that had already been stirred and scattered and concentrated by the events of the early solar system. Nothing about the ground beneath you is brand new. It is all inherited, recycled, assembled from what came before. That much is simply true. So we can hold the grand version of the story, the destroyed first solar system and the giant that unmade it, as the leading and most elegant account, while keeping an honest awareness that the details are still being worked out. The story is likely beautiful and explanatory, and it may be refined or revised as we learn more. That is not a weakness. It is what a living understanding looks like, a picture clear in its broad shape and still being filled in at the edges. It is worth understanding why such questions are so hard to settle, because the difficulty is itself part of the wonder. The events we are trying to read happened more than 4 billion years ago, in a system that has rearranged and resurfaced itself many times since. The first worlds, if they fell into the sun, left no remains. The rubble has been gathered and reworked. The surfaces of the inner planets have been melted, cratered, and renewed. We are detectives arriving at the scene long after the trail has gone cold, reconstructing the event from the faintest of marks. And yet the marks are real, and they are stubborn. The emptiness near the sun does not go away. The smallness of Mars does not go away. The near emptiness of the belt, its strange mixing, the stripped core of Mercury, the missing close-in worlds that other systems have in abundance, none of these dissolve under examination. Whatever the exact history, our inner system carries a set of features that a calm and undisturbed birth does not produce. Something happened here, even if the precise something is still being argued. What the future will bring is more of the mirror that has already transformed the question. As we find and measure ever more planetary systems, we will learn more sharply what is common and what is rare, and our own oddities will come into clearer focus against that background. As we study the rubble of our own system more closely, the asteroids and the icy bodies and the worlds themselves, we will read the signatures of the early events more finely. The story is not finished being told. It is being refined, year by year, as the evidence accumulates. There is a particular humility in holding a story this way, and it is a restful kind of humility rather than an anxious one. We are allowed to find an explanation beautiful and likely without demanding that it be certain. We are allowed to say that the destroyed first solar system is the best account we have of why our inner system looks as it does, while keeping an honest awareness that the details may shift. Wonder does not require certainty. Sometimes it is deepest precisely where the knowing runs out and the open questions begin. And perhaps that is the gentlest way to carry the whole of it into the night. The solar system holds a mystery in its very arrangement, a hint of worlds that came before, written in the empty places and the small worlds and the swept-out belt. We may never read it perfectly, but we can read it well enough to be moved, and well enough to feel how strange and how fortunate our own quiet corner is. The mystery is not a weight to bear, but a story to rest inside, large and old and unfinished, with room in it for sleep. And with the knowing and the not knowing both laid out, there is nothing left to do but gather the whole of it into a final stillness, and let it settle, and let you settle with it. For whatever the precise history, the result is the same, and the result is the gentle world you are resting in now, the quiet end of an ancient and eventful beginning. We turn, at the last, to that comfort and to rest. There is a comfort waiting at the end of this story, once the alarm of it has fully faded, and it is worth gathering slowly. The comfort is this: everything difficult in the tale is finished. The destruction of the first worlds, the giant's long fall, the churning of the inner system, all of it happened in the solar system's first chapter, ages before there was anyone here to fear it. Not one moment of that turbulence overlaps with a single moment of any life that has ever lived. What reaches us now is only the calm that followed, the long, quiet aftermath in which every living thing has had its entire existence. Think of the timeline as a whole. The upheaval we have followed played out within the first stretch of the solar system's life, a span of perhaps a few 100,000 years against a history now more than 4.5 billion years long. The chaos was brief, an early and passing turbulence, and the long, long remainder has been steady. We live in the steadiness, in the enormous quiet that came after the early storm had spent itself. Think, too, of where you sit in all of it. The Earth has circled the Sun billions of times since the rebuilding, settling ever deeper into its patient orbit. The collisions are over. The migrations are over. The orbits have long since smoothed into the calm circles we ride tonight. The world beneath you is not poised on the edge of any ancient violence. It is resting at the far, quiet end of it, in the long aftermath, where nothing dramatic happens at all. And consider what you are made of, because this is the gentlest turn of the whole story. The atoms in the ground, the iron in the rock, the water in the oceans, even the calcium in a sleeping body, were all somewhere before. They were part of the disk, part of the rubble, perhaps part of the first worlds that did not last, gathered and scattered and gathered again until they came together into the world we know and into you. Nothing in you is new. All of it is inherited. There is a kind of belonging in that, deeper than newness could offer. To be made of recycled material, gathered from the wreckage of older things, is to be woven into the whole long history of the solar system rather than set apart from it. The first worlds, if they existed, are not entirely gone. Some of their substance may be here, in the ground, in the water, perhaps in us, carried forward into the second draft. The lost generation may be quietly present in the one that followed. Consider, as well, the strange mercy of the giant. The same Jupiter that fell inward and unmade the first worlds is the Jupiter that now stands guard over the second, deflecting the comets, steadying the rhythms, keeping its distant watch. The destroyer became the protector. The force that once cleared the inner system now helps to shelter it. There is a wholeness in that arc, a sense of a story that turned, over time, from unmaking toward keeping. And consider the narrowness of the path that led to us, which is its own quiet wonder. Had the giant not fallen inward, there would have been no room for the earth. Had it not turned back, it would have ruined everything. Had it not stirred the outer ice inward, the earth might have stayed dry. So many things had to happen just as they did, and here is the result, holding still beneath you in the dark. The world you are resting in is the outcome of a path so narrow it is almost tender. None of this asks anything of you tonight. The history is finished, the orbits are steady, the giant keeps its distant watch, and the only thing left for you to do is rest in the calm that all of it produced. The story is large and ancient and strange, but its ending is small and near and gentle, and its ending is simply this: a quiet world, a steady orbit, a still night, and you within it, safe at the far end of an ancient and eventful beginning. So let the old violence stay where it belongs, far away and long finished. Let the first worlds rest in the light of the young sun that took them, ages ago, where they can trouble nothing now. Let the giant keep its faithful station beyond the belt, as it has for billions of years and will for billions more. and let the steadiness of the world beneath you be the last thing on your mind as the night settles fully around you. The solar system began in upheaval and ended in calm, and you live in the calm. The chaos that built this place ended before there was anyone to witness it, and all that remains of it now is the gentle world it left behind, the patient orbit, the quiet ground, the still and ordinary night. That ordinariness, we have seen, is itself the rarest and most hard-won thing, a piece assembled from wreckage, a second draft that became a home. Let the strangeness of the story be a comfort rather than a worry, now that we have followed it to its end. It would be easy to hear that our world was built from the wreckage of vanished planets and feel unsettled, as though the ground were less solid for having such a history. But the opposite is truer. The ground is exactly as solid as it has been for billions of years, and its eventful past is not a threat hanging over it. It is a story already told, complete, with a quiet ending that we happen to live inside. Consider how much had to go quietly right for this stillness to exist. The giant had to fall, and then to stop, and then to climb back out at just the right moment. The inner system had to be swept and concentrated rather than emptied entirely. The water had to be delivered from the cold. The orbits had to settle into circles patient enough to hold a stable world for the ages it takes for life to arise, and for someone, at last, to lie down at the end of a day and rest. Every step of it happened, and here you are. There is a softness in being late in such a story, in arriving long after the hard parts are over. You are not there for the falling of the giant, or the loss of the first worlds, or the rain of ice from the cold. You arrive now, in the long calm afterward, when the work is finished and the world is steady, and the only task remaining is to rest within it. The whole eventful beginning has resolved, over billions of years, into the simple gift of a quiet night. Let the giant keep its watch, as it has for longer than there have been living things to be watched over. Let the first worlds rest in the light that took them, troubling nothing now. Let the oceans hold their borrowed water, and the ground hold its borrowed atoms, and the orbit hold its patient circle, all of it settled, all of it still. The story that began in upheaval has become, in the end, the most ordinary and the most precious of things, a calm world on a quiet night, holding you gently as you drift. And so the first worlds are gone, fallen long ago into the light of the young sun, while the ground beneath you, gathered quietly from what they left behind, holds perfectly still. The chaos that built this place ended before there was anyone to fear it, and all that remains of it now is the calm. Let your breathing slow. Let the old violence stay where it belongs, far away and finished. Sleep well, and good night.